Back in episode 1, we mentioned 3 things happening under the hood every time you load a page: DNS, encryption, and HTTP. Since then, we've covered DNS, TLS encryption, and even flipped over to look at what's happening on the server side. Today, we're closing the loop with HTTP, the actual language your browser and a server use to talk to each other once the connection is set up. HTTP stands for Hypertext Transfer Protocol, and despite the technical name, the idea behind it is simple. It's a standardized way for a client, your browser, to ask a server for something, and for the server to respond every time you load a page, click a link, submit a form, or load an image. That's an HTTP exchange happening. And critically, HTTP is what's called a request response protocol. Your browser sends a request, the server sends back a response, and that's the basic unit of communication the entire web is built on. Every HTTP request includes a method which tells the server what kind of action you want. Think of these as verbs. Get is the most common. It means give me this resource, like loading a web page or an image. It doesn't change anything on the server, it just retrieves data. Post means here's some data, please process it. This is what happens when you submit a form, log in, or upload something. Unlike get, post can change something on the server's end, like creating a new account or saving a comment. There are others too. Put is used to update an existing resource. Delete, unsurprisingly, removes one. These methods give structure to what would otherwise be a chaotic, ambiguous exchange. The server knows exactly what kind of action is being requested just from the method alone. When a server responds, it includes a status code, a 3-digit number that tells your browser how the request went. You've probably seen a few of these without realizing it. Code starting with 2 means success, 200 is the classic, okay, here's what you asked for. Code starting with 3 mean redirection, the resource is moved somewhere else, and the server is pointing your browser to the new location. Codes starting with 4 mean a client-side problem. Something about the request itself was wrong. The most famous is 404, meaning the requested resource doesn't exist. And codes starting with 5 mean a server-side problem, the request was fine, but something broke on the server's end while trying to handle it. 500 error means the server hit an unexpected failure. These codes let your browser and you understand at a glance what happened without needing to guess. Requests and responses also carry headers, extra pieces of information that aren't the main content, but provide context about it. A request might include a header telling the server what type of content the browser can handle, or authentication information proving who's making the request. A response might include a header specifying what type of content is being sent back, a web page, an image, a video, or caching instructions telling the browser how long it's allowed to reuse this response before asking again. Headers are easy to overlook because they're invisible during normal browsing, but they carry a lot of the coordination that makes the exchange actually work smoothly. HTTP itself has changed a lot over time. The version most people are familiar with, HTTP/1, 1 sends requests one at a time in sequence over a connection, which works but isn't especially efficient. HTTP/2 introduced the ability to send multiple requests and responses over a single connection simultaneously, dramatically speeding up page loads that involve lots of small resources like images and scripts. HTTP/3 goes a step further, changing the underlying transport method entirely to reduce delays, especially on unreliable or high latency connections like mobile networks. Each version is backward compatible in spirit. Your browser and the server negotiate which version to use, but the improvements under the hood are a big part of why modern websites, despite being more complex than ever, often still feel fast. So there it is, the complete journey. DNS finds the address, TLS secures the connection, HTTP is the language spoken once everything's set up. And on the other end, servers, load balancers, and caching systems work together to actually handle the request and send something back. That's everything happening behind a single page load, most of it in well under a second, every single time you click a link. This wraps up the series, but it's really just scratching the surface of how the internet works. If there's a specific piece you want broken down further, DNS security, how databases actually work, what an API is, let me know in the comments. Thanks for following along. Subscribe so you don't miss the next series,